is the ripple problem? Stone thrown into 17 or 24 or something like that?
Yes,
All right, read it to me. Go. 17. Here we go. All right, black marker, go.
Were there repeats?
Yeah, there are a couple repeats.
Yeah.
Somebody read 17 to me.
All right.
Go ahead, Joe.
A pebble is dropped into a calm pool.
All right, watch. A pebble is thrown into a calm pool. Okay, go ahead.
Of water, causing ripples in the form of concentric circles. If each ripple moves out from the center at a rate of 1 foot per second.
All right, stop. So you've thrown a pebble into a pond. It forms ripples in the form of concentric circles, and the ripples are moving out from the center at a rate of what?
1 foot per second.
And what is that then? If the ripples are moving out from the center at a rate of 1 feet per second, what is that?
DRDs.
That's your change in your radius, because radius is measured from the center, right? So we got drdt. We know that. drdt is what? 1 foot per second. I like it. Okay, keep reading.
At what rate is the total area of
Stop. What are we looking for?
area?
We're looking for the rate of change for area. So we want to know. Keep going. So say that again.
At what rate is the total area of disturbed water increasing at the end of 4 seconds?
So I want to know when t equals 4. That's interesting. We hadn't even talked about time before, but we'll remedy that. Don't worry. All right, so we have this. We talk about circles in a pond, ripples forming. What are the things that are changing in that circle? The area. What else? Radius. Can you think of anything else that really matters right now? No. So we just got area and radius. That's really simple. And I told you they're not going to give the area formula. So what is the area of a circle? So there's the formula that connects them. That's really all you want. And then just go through that formula and say, okay, is A changing? Yes. Is R changing?
Yes.
Yes. So they're changing. You can't plug in for them until you do what? Take the derivative implicitly with respect to time. So let's do that. What's the derivative?
Are we ever gonna have to take like just normal derivatives over again?
Yeah, oh gosh, yeah. Lots again, starting tomorrow. Okay, what is this? 2 pi r times
R times
dr dt. I want to know dA dt. Okay, so let's do that. dA dt is going to be equal to 2 pi. Do we know r?
Basically, yes.
How do I know r's 4?
Because 1 foot per second. And
Good.
4 seconds.
If the radius is moving 1 foot per second, then 4 seconds later it would have to be at 4 feet. Everybody? You did it? All right, think about it. 1 second later, you'd be at 1 foot, because it's going 1 foot per second. 2 seconds, it'd be at 2 feet. 3 seconds, it'd be at 3 feet. 4 seconds, it'd be at 4 feet. How many of you feel like, oh my gosh, really? How many didn't get that far? Everybody got this one? Why am I doing it? All right, anyways, 4 centimeter feet, okay, times drdt is 1 foot per second, which is going to give us, by the way, feet squared per second, right? So we're going to end up with 8 pi feet squared per second. How many of you got that one? Really, like legitimately, you got that one on your own. Okay, not bad. How many of you see what you did? Okay, read the pressure volume one. I like this problem.
Which one is that again? That is.
Okay, I don't know which one it is. Can you guys tell me?
It's like
It's like
It's the gassy problem.
Oh, 15.
15.
15. Read that one to me. I like it.
I don't.
This problem is such a gold nugget. Go ahead, 15.
Expands adiabatic.
When gas expands, sounds smelly. Okay, go ahead.
Pressure and volume are related by the equation P.
No, start again. Start again. Read it from the very beginning.
When gas expands adiabatically.
Adiabatically. Do you know what adiabatically is? Neither do I don't care. Okay, some things are just telling you if they sound smart. Actually, I do know a little bit about it, but I really don't care. Okay? So when gas expands adiabatically, it has something to do with no energy change, correct, Canyon?
Yeah, there's no heat transfer.
Okay, that's all we wanted to know. All right, keep going.
Can you start over again?
Yeah, start one more time.
Okay. When gas expands adiabatically, its pressure and volume are related by the equation PV to 1.4 equals K.
Stop. All right, so pressure and volume are related by the equation PV to the 1.4 is equal to K. And I know some of you are kind of wigging out right now. You're like, well, where's the picture? Do you need a picture if you've already got the equation?
No.
What's the point of the picture? I don't know. It's adiabatically. All right, here we go.
Where k is constant.
Where k is constant, okay?
Find the rate of
Really important. K is what?
constant.
So if we take the derivative of it, it's what? 0.
Find the rate of change in volume.
Stop. We want to find what?
Rate of dv dt.
We want to find, quiet, Candy. We want to find, hush, adiabatically. No energy change out of that mouth. Okay, dv dt. I want to find dv dt. Go.
What do you mean?
Keep
When
reading.
p equals 10 and v
All right,
equals
I want to
20.
find dv dt when p equals 10 and
v equals 20.
v equals 20. All right, so that's what we're after. We're after this when this. We're after this when this happens. Okay, keep going.
Assuming that the pressure is decreasing 2 units per second.
Stop. Assuming the pressure dp dt, diamond cutter, is negative 2 what?
Units per second.
Units per second
At that instant.
at this instant. So when this happens. Okay, what's the question?
Is the volume decreasing or increasing?
Oh man, they're so nice. Is the volume increasing or decreasing? So all you got to figure out is when you get this answer, if it's positive, it's what? Increasing. If it's negative, it's what? Decreasing. And I'm talking about volume and pressure. Do I have an equation that relates volume and pressure? How nice of them to give us the equation that relates volume and pressure. This is a gold nugget problem. You didn't have to do anything. Well, I guess you did have to do a little bit.
If it was free response and we just put decreasing, would we get
This wouldn't be for responses to be multiple choice. Because they gave you the equation. Now, there is something hard about this problem. Anybody tell me what's hard about this problem? I have the equation that relates them. I know what I'm looking for. I'm looking for dv/dt. So what am I going to do next? And what's hard about the derivative here?
Oh, it's product.
You got to use product rule. And remembering to do implicit differentiation with respect to time. So I'm going to be doing the derivative of this, but using product rule. So remember, there's two functions here. There's p and v. This is constant. Who cares about that? Okay.
It's going to be dp over.
So what I'm going to do is derivative of the first. What's the derivative of p?
dp over dt.
1 times dp dt. That's it. That's the derivative of the first function times the second function. What's the second function?
V.
You know how many people are going to forget that? Because they're going to be so worried about taking the derivative of the first, they're going to forget to multiply it by the original second function. Plus,
1.4.
I'm going to go ahead and write p though. First function
Times 1.4 p to the 0.4.
times 1.4 times p to the 0.4
V. Sorry. V.
v. Okay, times 1.4 times v to the 0.4 times what? Times what? Times what? 1, but
dv dt.
dv dt. You know how many people are going to forget that little piece?
Probably not many because we need that.
You do need it, so
Yeah, you
hopefully
can.
nobody forgets it.
That's the only thing.
So hopefully nobody forgets it. So derivative of the first times the
Second.
plus the first times the derivative of the second. Do you see it all?
C.
Derivative of the first times the second plus the first times the derivative of the second. And remember to do it implicitly, so when you do the p, when you're doing the derivative of p, you got to remember to use chain rule, multiply by dp dt. When you do v, you got to remember to multiply by dv dt. Okay? We're rocking this out, man. Now it's just plug in and figure out the answer. We know dv dt. This was negative 2. What was v? Get your calculator out. This would be 20 to the 1.4, and I'm going to show you something here that would be helpful. What's p? 10. That's a 10 times 1.4 times v, which is 20 to the 0.4 times dv dt equals 0. Now, let me talk about this. I'm only after, the question asked, is the rate of change for volume increasing or decreasing? I only really need to figure out if dv dt is going to be positive or negative. I can do that without a calculator. You know that? Because if I move this to the other side, what's going to happen to it? If I move it to the other side, it's going to become positive 2 times 20 to the 1.4. Follow me here. Divided by this, so that I can solve for that, which will be 10 times 1.4. If you want to make that a little bit simpler, you can make that a 14 times 20 to the 0.4. Now look at that. Without even plugging it into your calculator, what does that answer have to be? It has to be positive because there's only positive numbers there. So therefore, it's what? It's increasing. But let's figure out the answer just for kicks and giggles. What's 2 times 20 to the 1.4 divided by 14 times 20 to the 0.4? And if you're going to do it all together, you got to make sure the whole denominator's in parentheses or you're not going to get it
Can
right.
you just take 1.4 minus 0.4 and get rid of that 20 at the bottom?
Ooh, I didn't even think of that. You could. You could go 20, you could cancel that one and make that 20 to the what? First. Ooh, I bet this was non-calculator. So it'd be 2 times 20 over 14. 2 goes into 14 what? 20 divided by 7. What is 20 divided by 7? Just for decimal sake. 2 point what?
But why is it saying it's increasing there, but it's
Positive. Positive is increasing.
but it's decreasing on our other?
Because they're probably inverse related. There's an inverse relationship between them. They're not directly related. As one goes up, the other goes down. And kind of makes sense if you know anything about pressure and volume. As you increase, I know pressure and volume are inverse related in physics. So as one goes up, the other goes down. As one goes down, the other goes up. Isn't it why when it gets really, that's temperature and volume, I think. If the temperature goes down, what happens to the pressure? It goes down because that's when you take an air balloon outside, really cold weather, what happens to the air balloon? It just kind of shrivels. Okay? Alright, isn't that cool? How many can handle that though? Get a little bit better? This to me, I think, puts it over the top. Number 20, you understand number 20? I don't think you can understand a related rate problem. Now, to be able to do them on your own, you just need practice. You just need practice to keep reading and keep struggling it through it. Tonight, you're going to go up to 55. Now, the reason I say we're going up to 55 is because I know you're not going to have all 55 done. I am a realistic person. Okay? You're luckily going to have 2/3 of it done because there's going to be problems you're going to get to and be like, I have no clue. I literally don't even know where to start. And you're going to try and you're going to write some things on your paper and you're not going to get it done. And that's okay. But I'm hoping out of those 55, by tomorrow, you've got at least 2/3 of them done. I'm going to create the answer key for it. All of them worked out for you. And I'm going to do it from scratch tonight. I'm going to see how long it takes me to do all 55 from scratch tonight.
You also have the masters in math, though. Not quite technical.
The point taken is I gave you 4 nights. I'm doing it in 1. Okay? But I just want to do it because the only reason I'm doing it is because I'm not so educated last year. Okay, so I have to do it. But I want to do it because I want you to be able to go through and look at them. Okay, so I'm going to work them all out and show you what I did so you can kind of. But now that we've been working on it for 3 days, hopefully you're going to get some of these and then you're going to go back tomorrow and be like, sweet, yeah, I got that one. Ooh, I see why I didn't get that one. Wow, I see why I didn't get that one. Whoa, I have no clue why I didn't get that one. Okay, so it's going to be different for each one. So here we go, number 20. I love this problem. Partly because I get to draw, and you guys are going to help me because I'm terrible at drawing. But watch, you guys, I'm going to show you how much you actually understand that you don't think you understand, but you really do understand, okay? Water is flowing into a trough. So we got this trough at a rate of 100 cubic centimeters per second. What is that? That's your dVdt. So dVdt is 100 cubic centimeters per second. Got that? The trough has a length of 3 meters and cross sections in the form of a trapezoid. Now let me explain cross sections to you. Really simply, you take a loaf of bread out and you're Amish and it doesn't come pre-sliced. You're going to have to take a knife out and do what? Cut it. What? Just think of a cross section as one slice, infinitely small with its, okay, its width, its width is infinitely small. Tongue twister. Okay? So, just think of a very thin slice of that loaf. That's a cross section. You ever seen a cross section in an anatomy textbooks of your body? It's just one slice of your body. If I was to actually take And if you've watched the TV show Hannibal,
like-
which you probably shouldn't,
MRI scans.
an MRI scan shows a cross section. It's just one slice if I was to take. And in that show, Hannibal, he took oh, it's really creepy. He took glass, like 1,000 sheets of glass, and cut up a person. So he took the glass and just went right through the person standing still, and they were held together. Glass. It was really creepy. Yeah, Hannibal. Yeah. So anyways, a cross section of a loaf of bread would just be one slice of the bread. What would the shape of that cross section be? It's a rectangle. It's a square. Okay, kind of with kind of around the top.
Okay,
Is your loaf. But your loaf of bread looks like this. One cross section would be this.
I get where you're getting.
Okay, it looks like that.
What it
Madam?
look like
Thank
the,
you.
the loop on top.
Yeah, that's what I'm trying to do. So there's your loaf of bread.
Yeah.
Piece of toast. Okay, cross section. One dimensional. You have to imagine its width infinitely small or approaching zero. Okay? So a cross section is that. So a trough has a length of 3 meters in cross sections that form trapezoids, whose height, the trapezoid height is 50 centimeters, whose lower base is 25 centimeters and upper base is 1 meter. At what rate is the water level rising when the depth of the water is 25 centimeters? Let me read that again. At what rate is the water level rising? So height, so I want to know dH dt. So I want to know dH dt when what? When h is 25 what? Now, I hope you notice right away that there's something very irregular about this problem.
There's a meter.
You got meters and centimeters. You're going to have to convert one to the other.
Almost per meter.
I would convert meters into what? Makes it really simple. So let me go ahead and draw the end of the trough, one cross section of it, and then we'll create an infinite number of cross sections to form the whole trough. Okay? So here we go. Here's a trapezoid. If you don't know what a trapezoid is a quadrilateral with a pair of parallel sides. So you have to imagine, okay, here's the top, here's the bottom. They are parallel. Those are called the bases. One base is going to be shorter than the other. If it wasn't, then it would be a rectangle. Okay, but, so here we have this trough. Try and do a good job here. This is going to be magnificent. No, that's terrible. Is that pretty good? Okay, there's a trapezoid. A trapezoid is a quadrilateral four-sided shape with a pair of parallel sides. The sides that are parallel, really important here. The sides that are parallel are called the bases. Now, we usually label the smaller base, base 1, but it really does not matter. So I'm going to call the smaller one base 1, and I'll call the bigger one base 2. But that is irrelevant. Okay, let me tell you, that is irrelevant. Now, what did they tell us that the lower base was?
25 centimeters.
25 centimeters. What did they tell you the upper base was? 1 meter, which is 100 centimeters. What else have they given you about this trapezoid? Its height, the height of the trapezoid, it says cross sections of a trapezoid. Height is 50 centimeters. The height is the perpendicular distance between the two bases. It's the direct distance between the two bases. So the height is 50, if you will, centimeters. And same thing here. So 50. Okay, that's the height of the trapezoid. Do you remember a trapezoid now? Has two bases. The bases are always the what? The two sides that are what? Parallel. And the height always connects the two bases. And it's the perpendicular distance between those two bases. Now, the length of this trough is what? 3 meters. Now you got to imagine. This trough goes out like that. And this trough goes out like that. And then it has a bottom. And then if I do this correctly, and I never do, but I'll try. Pretty good? We're going with it.
It's getting bigger.
Yeah, it's a lot. And then it's got to go,
Isn't there like a
hush.
solid shape on this whiteboard?
Oh no, just leave it alone.
I see it. It's up there. Oh, that's really good. Like, here we go. Wasn't that bad.
It's good enough. It's a distorted trough. Okay, stinking pigs. All right. So the length of the trough is what? 3 meters, which is 300 centimeters. Are you with
How do
me?
you know that?
They told us the length of the trough is. The trough has a length of 3 meters, and its cross sections are trapezoids. So if you take a slice of the trough, you're going to get a trapezoid. Okay? At what rate is the water level rising? Now, here's the deal. We're talking about the volume of the trough. The volume of the trough. I need the volume formula for a trough. Well, a trough is a rectangular prism. And if you were to stand the trough up so that the trapezoid is sitting on the ground, take the trough, prop it up, this would become the base of the trough. The length would become the what? The height of the trough. And if you remember the volume of a prism, it's the area of the base times the what? Height. This height, though, is different from the height of the trapezoid because this height is really talking about what? The length of the trough. So think of this as, all right, area of the base. What is the base? It'd be the area of a what? A trap times the length of the trough. You see how I got that? Make pretty good sense? Okay? So it's going to be area, or sorry, volume. And when you get area, this is units squared times length. That becomes units cubed. So we got volume. It's going to be the area of the trap. How do you do the area of a trapezoid? They remembered last hour. Let's see if anybody remembers. 3 people remembered, just so you know.
Base times like minus like I don't know, like the triangle or
Right, base, what'd you say?
whatever.
Times something else.
Height.
Times height. This is what I always tell students to remember. You have to memorize this one. This one shows up on the AP exam like 6 times. Because we have a formula called trapezoidal formula for integrals. You need to know the area formula for trapezoid. Memorize it right now. It's the average of the bases times the height. Average of the bases times the height. So if you think of it, average of the bases, all right, base 1 plus base 2, there's only 2 of them, so average would be divided by 2 times the height. So there's the area of the trap. There's the area of the trapezoid. Times what? The height of the trough, which happens to be really what? Because we tipped it up. The length. So there's our formula. Now, let's look at it. Let's talk about it, because anytime before we take the derivative, we should talk about what's changing and what's not changing. Because how many variables are in this problem? 1, 2, 3, 4, 5. I count. That's a lot of variables. Okay. Does the volume change as we fill this trough up? Yes, and in fact, that's the one we want. That's the one we know. Does the height change of the trapezoid as we fill up the trough?
Yep.
Yeah. What?
The height of the trapezoid?
The height of
The water level?
Oh, the water level.
Yeah. That one changes. What about base 1?
No.
As you put water in this trough, is the base 1, is the lower base ever going to change? The water at the lower base is always going to be what? 25. This one doesn't change. You can plug 25 in for this one right now. That's slick. But as you fill this up, will the base, the top, so wherever the water level sits, will that base, the upper
Yeah.
base, be different?
Yep.
It changes as, eventually it'll get to a what? When it's full, it's what? When it's empty, it's what? So it goes up, the upper one's changing, but the lower one's not changing. So we can't replace B2. L, the length of the trough. As you put water in this, will the length ever change? The length's always 300, so we can plug 300 in for that one.
Would it be
All right, let's talk about base 2. That's a problem.
Would it be 1/4?
Because I'm interested, I know dV/dt. I want dH/dt. I don't care about dB2/dt. Okay, neither does R2D2. All right? So we need to get rid of this one. Well, we've been doing similar triangles. I don't see why we can't do similar trapezoids. Because at any height, aren't these trapezoids always going to be similar? Yeah, because once you're going to be able to show it, and somebody will be like, how can you do that? Well, let me draw a trapezoid just real quick. That's like Illuminati. All right, but anyway. So if I pick any trapezoid, any height, this trapezoid right here is similar to the what? Big one, because these angles are congruent, because these 2 lines are parallel, and then corresponding angles would be what? Congruent. These will be congruent because they're reflexive, so all 4 angles in the trapezoid are congruent. Once you show all the angles are congruent, the 2 trapezoids are similar, therefore the sides are what? So the sides are in proportion. So once we do the sides, we can do any proportion we want. So I can do B2, the upper base to the height would be equal to what? 100 over 50.
Oh, yeah.
The height's 50, right?
Oh,
Let me just finish. So 50 B2 is equal to 100 H. So if I solve for B2, it'll be what? 2H. So just let me get this finished for you. I won't finish the whole problem, but you'll have H. B1 is 25. I'm just going to put the 1/2 out front. Are you okay with that? 1/2 H. B1 would be 25. B2, we just found it to be 2H. Times L is 300. Which, by the way, that's centimeters, so that's going to get take into account units. And then I would definitely simplify this before I do it. I can do 1/2 of 300 and make that a what? 150. So that would be 150H times 25 plus, look how easy this is getting now. Got rid of all that crap. And just let me tell you what the final equation would be before you take the derivative and then you guys can go. So it'd be V is equal to what? I think it's 3750H plus 300H squared. You would take the derivative of it and plug in your numbers and be done. Once I get you here, it's gold. Simple to do.
This is getting.
It's getting there, the hard part. Which, by the way, they don't do troughs. They make the exams. They are fun to do. Okay. See you tomorrow. Do that back side of that free response. It's on implicit differentiation. See if you can get that, and then try and get up to 55. Try and do as many as you can.